When we look up at the night sky, or picture our planet from the cold expanse of deep space, we see a lonely blue marble drifting in the void. But imagine if our homes suddenly adopted the magnificent arcs of the solar system's most famous neighbor. What if Earth had giant, glowing rings? This animated diagram shows how these structures actually operate. They aren't solid hula hoops or optical illusions. They are trillions of individual pieces of physical matter, dust, ice, and rock, all trapped together in a flat, high-speed orbital disk. Planets don't just grow these structures out of thin air. For Earth to acquire a ring system, a massive celestial body, like a rogue asteroid or a small stray moon, would have to wander dangerously close to us. If that object crossed the Roche limit, the invisible boundary where our planet's gravitational pull becomes stronger than the object's own internal gravity, Earth would overpower its structural integrity, tearing the rock to pieces. Over millions of years, those shattered fragments would crash into one another, grinding down and spreading out to form a permanent, stable field of debris circling the equator. So while those glowing bands in the sky would look breathtaking, they are actually a celestial graveyard. We would be staring at the remains of a destroyed world. But Earth doesn't exist in isolation. We already have a massive companion sharing our immediate orbital space. This orbital map shows Earth in the center, surrounded by the ring field and the Moon's path. Overlapping gravity waves highlight the tension between them. Because the debris field holds tremendous mass, it exerts its own pull. Over extremely long periods, this added weight would warp the Earth-Moon orbital mechanics. This dynamic leads to orbital resonance, a process where the Moon's gravity periodically tugs on specific sections of the rings. The Moon would actively pull fragments entirely out of their orbit, either flinging them into deep space or raining them down into our atmosphere. The ring system and the Moon would exist in a permanent gravitational tug-of-war, creating an active environment where particles are constantly being stripped away or pulled out of alignment. If we drop our perspective down to the top of Earth's atmosphere, we encounter a much more immediate problem: how those rocks interact with incoming sunlight. Even though they look translucent from afar, a planetary ring system is incredibly dense. It acts as a massive physical barrier to solar radiation. Depending on the thickness and angle of the debris, the rings would plunge specific regions of the globe into sharp, imposing darkness. This 3D model demonstrates how Earth's axial tilt complicates the picture. As we orbit the Sun, the resulting shadow band migrates toward the hemisphere experiencing winter. Notice the line chart overlaying the deep blue shadowed zones. We see a steady downward trend in regional temperatures for areas caught underneath. The rings operate as an enormous orbital sunshade. By permanently altering how solar energy reaches the surface, entire ecosystems would be forced to adapt to an artificial, freezing twilight. A localized temperature drop is alarming, but Earth's atmosphere is a highly connected engine. While the shadows wouldn't instantly freeze the oceans or end humanity overnight, the severe, uneven heating of the Earth's surface would rewrite global weather patterns. Changing where the sun hits changes where the wind blows and the rain falls. Regions bordering these shadow zones would experience entirely new, unpredictable climate cycles, deeply disrupting the agriculture that feeds billions. These rings would force a systemic disruption of the global climate patterns that human agriculture and settlement have depended on for thousands of years. Yet, despite the environmental cost, standing on the ground and looking up would reveal a sky that looks nothing like the one humanity has known since our earliest ancestors. Imagine walking through a bustling metropolis, glancing above the skyscrapers, and seeing a glowing celestial highway spanning the entire horizon. During sunset and deep into the night, the rings would blaze with vivid color. The ice and rock suspended high in the atmosphere would remain directly exposed to the sun, reflecting its light back down to the dark surface below. This split-screen graphic shows exactly how that view changes depending on your location. At the equator, the rings appear as a single, intensely bright, thin line slicing through the zenith. But from the northern latitudes, they spread out into a massive, sweeping dome. This permanent feature would provide astronomers with a natural overhead laboratory, allowing them to study planetary physics and orbital dynamics directly from their backyard. Our sky would become a breathtaking alien landscape, heavily influencing everything from ancient mythology to modern scientific discovery. This leaves us with a stark trade-off. We would gain a glowing, permanent architecture in our sky at the cost of physical and climate-based disruptions on the ground. Trillions of tons of shattered rock and ice silently gliding through the void, casting their shadow over humanity. So if you had the power to reshape the solar system, what would you choose? Is a ringed Earth the ultimate dream scenario, or an environmental hazard we are lucky to live without?